Hello students, now in this video let's solve the next problem of assignment problem. Example, consider the problem of assignment of 5 operators 5 machines. The assignment values are given below. Assignment values are given below. The assignment values are given. So here machines, here operators, machines 1, 2, 3, 4 and 5, and the costs are 10, 5, 13, 15, 16. Here 3, 9, 18, 3, 6, 10, 7, 2, 2, 2, 5, 11, 9, 7, 12, 7, 9, 10, 4, 12. The question is that assign the operators to different machines. Assign the operators to different machines so that the total cost is minimized. That is the question. So now answer or the solution we can say. Now here first of all we have to look, is it balanced or unbalanced? Now you know number of rows equal to number of columns, so it is a balanced assignment problem. Since number of rows equal to number of columns, therefore AP is balanced. Now we know we want initial basic feasible solution to do an assignments. Now in that one, you know, we need zeros in all rows and all columns. So for that we are doing subtraction for rows and subtraction for columns. So if required we will do the other one. Now let's do the subtraction for rows. Subtraction for rows. So let's do it. In that one what we have to do, we have to subtract the minimum element or the minimum value from each row, from each element. That gives us zeros in all rows and all columns. That will be our initial basic feasible solution. Now look at this first row. What was the minimum here? 5. So we will subtract this 5 from each and every element or the each and every value. So here we get 5, 0, here 8, 10 and 11. Then minimum is here 3. So 0, 6, 15, 0 and 3. What about this? Minimum is 2. So 8, 5, 0, 0, 0. Here minimum is 5. So 0, 6, 4, 2 and 7. Again, what is minimum in this row? Minimum in this row is 4. So we get, it will be what? 4. So 3, 5, 6, 0 and 8. These entries we are getting. Now look at, in each row we have a 0. Fine. What about the columns? In each column we have a 0. So this is an initial basic feasible solution. So I can say it is an IBFS. It is an IBFS. So now what was for optimality? Let's see for optimality. Optimality. So here for optimality we need to do an assignment. So we have to examine the rows with single 0. So let this first row have a single 0. So I will do square for that. Then I will cross the corresponding zeros of corresponding column, but there is no 0. Fine. Now the second row have 2 zeros, so don't do the assignment there. Third row have 3 zeros, so don't do the assignment there. Fourth row have a single 0, so let me do an assignment here and I will cross the corresponding column 0. Fine. Now fifth row have a single 0, so I will do that assignment and I will cross these corresponding column zeros. Fine. Now this is about the rows. Now look at this column have an assignment, this column have an assignment, this column have a single 0, but there will be no assignment. So let's do this assignment and here we will cross the 0 of the corresponding row. Okay, so here we have done the assignment, but this last one doesn't have an assignment, so this is not an optimal solution. So what can I say? Since second row and fifth column has no assignment. Therefore assignment cannot be made. Therefore assignment cannot be made from this IBFS. So here we need improvement, or if you observe, minimum number of lines passing through all zeros are not equal to the order of this assignment problem or this matrix, cost matrix. If you observe here, if we draw the lines from this second and third row, first and third row, let's do the lines passing through first and third row and in these columns, then you will get all the zeros are get covered. Look at it again. What I say, if I draw a line passing through first and third row and from first and fourth column, then look at the remaining are nothing but the non-zero entries, while all zeros are get covered in these lines. Means how many lines are these? 4 that are not equal to the order of this cost matrix. Therefore this is not an optimal solution. If it is equivalent to order of this matrix, then it will be an optimal solution. So now here these lines I have been observed, but not necessary always every student is able to observe these lines. So now for this one, let me tell you one procedure for getting these lines which gives us minimum number of lines which cover all the zeros, so that you are getting a improved cost matrix here to get an optimal solution to this assignment problem. Now the procedure to get these minimum number of lines is known as the ticking procedure. So let me tell you the steps for ticking procedure. Here in this problem itself, let me tell you ticking procedure. Ticking procedure. In the ticking procedure, the first step is step 1. Step 1 says tick all unassigned rows. Tick all unassigned rows. Now if you observe here carefully, then look at here carefully. In this row there will be an assignment. In this row there will be no assignment. So unassigned row means this one here. I will tick it as such. Now this row have an assignment. This is also has an assignment. This is also has an assignment. Fine. Now first step says tick all unassigned rows. Now here only one, so I am ticking that one. Fine. Now here for your understanding, let me tell here second row. Okay. Now second step says tick the column of cross zeros in ticked row. Tick the column of cross zeros in ticked row. Means what? Now look at here, this second row doesn't have an assignment, so we haven't tick it. Fine. Now this row have two cross zeros. This row have two cross zeros. This one and this one. Fine. So we have to tick that corresponding column. This one. I am ticking this. Look at it as such. This is my unassigned row. In unassigned row there are two cross zeros. So first cross zero is in first column, so I am ticking that one. Then other cross zero is in this fourth column, so I am ticking that one. Tick the columns of cross zeros in ticked row. So here which columns are these? So here first and fourth. Here first and fourth column is as such. Fine. Now the third step says we have to tick the rows of assigned zeros of ticked columns. Tick the rows of assigned zeros of ticked columns. Now in first column there will be an assigned zero here, so we have to tick that row. Tick the rows of assigned zeros of ticked columns. Ticked columns are first and fourth. So in first column there will be an assigned zero in this fourth row, so I am ticking fourth row. Fine. And in fourth column there will be an assigned zero in fifth row, so I am ticking fifth row as such. This is our ticking procedure. Now here onwards what we have to do? These three steps only here. So this ticking procedure will provide the minimum number of lines to cover all zeros by the way what we have to do for that? By the way, here we have to draw straight lines. Draw straight lines. Draw straight lines for unticked row. For unticked rows and ticked columns. Ticked columns. This is very important. We have to draw the straight lines for unticked row and ticked columns. So now if you observe here carefully, as I have been observed these lines here previously, so I have been drawn these lines. So if you observe now, second, fourth and fifth row is ticked, but we have to draw the straight lines for what? Unticked rows. Unticked rows are which one here? First and third one. So I am drawing a line for first and third row, okay. And ticked column. Ticked column is which one? This first column and fourth column. That gives us the minimum number of lines which cover all zeros. Now from this we will get improved table. What was the improved table? In improved table, as you know, in previous example we have done it. So in improved table, what we have to do? We have to find a minimum among these uncovered entries. Minimum of these uncovered entries. So what are these? 6, 15, 3, 6, 4, 7, 5, 6, 8. So minimum of them is 3. So this 3 we have to add at this intersection position. At this intersection position of these lines, and we will subtract that one from these uncovered entries. That we have to do. That gives us the improved table. So let's do that one. Therefore, improved table is what does that? It will be other entries are as it is. Simply at intersection position we will add that element, and from other uncovered entries we will subtract it. So here 3 is the minimum, so I will add 3 in this 5, so 8. This will remain 0 as it is, this is 8 as it is, this 10 will become 13, this is 11 as it is, this 0 as it is, but from this 6 I will subtract 3, so it will become 3, this is 12. Here this 0 as it is, because there will be no an intersection. Here this 3 is get subtracted, so 0. Here this 8 is intersection position, okay. So horizontal and vertical lines are meet there, so it will be an intersection position, so this will become 11. Here this 5 as it is, this 0 as it is, this is also intersection, so it will become 3, this 0 as it is, this is as it is, this 6 will become 3, here 1, this 2 as it is, this 7 will become 4, so we have to subtract from there, okay. This 3 as it is, this 5 will become, this 5 will become 2, this 6 will become 3, this 0 as it is, 8 will become 5. As such, this is our improved table. Now here let's try to do the assignment. So now again this row having a single 0, so let me do a square. I will assign that one by covering it by a square, okay. There will be no 0 in this column, so keep it as it is. Now this second row have 3 zeros, so don't do the assignment there. Third row having 2 zeros, so don't do the assignment there. But this fourth row having a single 0, let me do the assignment here. It will get crossed, fine. The fifth row having a single 0, so let me do assignment here. It will become cross. Now the second row having a single 0, so it will get cross. Now again this one having a single 0, it will get covered, okay. So as such, in each row and in each column we get the assignment, means it is an optimal assignment here. So since for each row and each columns has single assigned 0, hence it is an optimum assignment. It is an optimum assignment. Okay, and that optimum assignment schedule is, now if you know, these are machines, so first, second, third, fourth, and what, fifth, and these are operators 1 2 3 4 5. Okay, so optimum assignment schedule is what does that? Now if you know, here these operators 1 2 3 4 and 5. Now operator 1 will assign to which machine? This is a second machine, so second. Operator 2 will assign to which machine? This is fifth one. Third will assign to third one. Fourth will assign to first one, and fifth will assign to fourth one. Okay, and the minimum cost is, what does it? It will be 1 into which matrix we have to look? We have to look the original matrix in the given problem. So here for this second one having a cost 5, then fifth one having a cost 6, so this will become, this is what, 1 into, this is 1 into 5 plus 1 into 6 plus, for third one it will be this position, so what is the cost there? 2, this 2, 5 and what, 4, so this will become 1 into 2 plus 1 into 5 plus 1 into what, 4, so this will be 5 plus 6 plus 2 plus 5 plus 4. This is the minimum one, so it is rupees 22. This is minimum cost for assigning these operators to these machines. As such, this problem is get solved. Now let me solve the next problem, next example. Similar type of example. Suppose having the assignment cost matrix is suppose as such. Here the costs are 160, 130, 175, 190, 200, 135, 120, 130, 160, 175, 140, 110, 155, 170, 185. This is 50, 50, 80, 80 and 110. 55, 35, 70, 80 and 105. So now here also we have to assign here so that the cost will be what? Minimum. So now in this problem, let me do this one using, first of all, in general we are doing subtraction for rows first, but it is not a rule, hard and fast rule there, so we have to start from subtraction for rows only always. Let's do here the subtraction for columns. So subtraction for columns. Subtraction for columns. Let's do it. This is a solution. You should write first that it is what? Balanced assignment problem. That is your job. You should write those things. And now I am doing subtraction for column first. So by doing subtraction for column first, what we get? Our matrix will become now in this column the minimum is 50, so I will subtract it from 160. It will be 110. Here it will become 85. Here it will be 90, 0 and what? 5. Here minimum is again 50, so here it will become what? This will be, sorry, minimum is 35, not the 50. 35 is the minimum here, so it will become 95. Here it will be 85. Here it will be 75. Okay. Here 15 and here 0 we are getting. Here minimum is what? 70. So it will become 105. This is 60. This is how much? 85. Okay. This is 5 and 0. Here the minimum is what? 80. So it will become 110. This is 80. This is 90, 0 and 0. What about this? Here minimum is how much? 105. So it will be 95. This is 70. This is 80. This is 5 and what? 0. As such we get. But now this is not initial basic feasible solution. Look at here, this row having a 0, this row having a 0, but there will be no 0 in first 3 rows. So let's do subtraction for rows also. Subtraction for rows. Subtraction for rows. So what we get here? Subtraction for rows. So here minimum is what? 95 here. So this in first row minimum is 95. So first row will become here 15, 0. This will be 10. Here 15 and what? 0. What is minimum here? Minimum is 60. So this will become 25. There also 25. Here 0. Here 20 and what? 10. Here minimum is what? 75. So here we get 15, 0, here 10, again 15 and what? 5. Okay. Here these rows remain same because the minimum is what? 0. 0 is get subtracted. It doesn't affect. Here 5, 0, 0, 0, 0. Now look at in each row there will be 0. Means in each column also there will be 0. So this is an initial basic feasible solution. It is initial basic feasible solution. So now let's do the assignments. Now in first row there are 2 zeros, so we can't do the assignment. The second single 0, so let me assign it. Let's cover it by a square and cross corresponding column zeros. So this is get crossed. Now third row having a single 0, so let's cover it in a square. Okay. And cross the corresponding column 0. Now the fourth row having 2 zeros, fifth row also having 2 zeros. So let's go for columns. So now in first column there will be a single 0. So let me cross the corresponding. Sorry, one more thing. When we have been covered this one, so we have been cross it. We should cross this one also. Okay. Now Due to that, in first row there will be a single 0, so I can cross this one also, and here a single 0 is left, so I can assign this. So now since for each row and each columns has single assigned 0, hence it is an optimum assignment. It is an optimum assignment. And what is optimum assignment? Gives the total minimum cost. Therefore, the total minimum cost. What was the cost? Here 1 into, at 5th position, what was the cost here? 200. So 1 into 200 plus 1 into, at this position, what is in original matrix? You should look it 130. So 130 plus 1 into, at this position, what does that? 110 plus 1 into, what is here? 50 plus 1 into, what is here? At this position it will be 80. So this is 80. So it is 200 plus 130 plus 110 plus 50 plus 80. So it is 570 rupees. It is rupees 570 only. Now the same problem I am giving you as an homework for. Now here I have been did subtraction for columns first, but you are doing subtraction for rows first and then solve this one. Check this, it must give the same minimum cost. Remember this thing. You have to do firstly, I have done firstly subtraction for columns. You have to do firstly subtraction for rows and solve this one. You should get the same cost. If required, use a ticking procedure. Remember, in ticking procedure, first step we have to do the ticking at unassigned row. Then in unassigned row, corresponding columns in which the cross zeros in that unassigned row. Then further what we have to do? We have to tick at the rows of assign wherever the assignment was done. Okay, in those ticked columns, and then later on finally we have to draw the straight lines for unticked row and ticked column. That will be our ticking procedure. Try to use that one for this example. That will be an homework for you. Thank you.